Hi, today we are going to look at arcs of sectors. So first of all, think about what a sector is, and actually below are examples of sectors. They're parts of circles, but not the whole circle in general. And then arc is this length here. So we want to be able to calculate arcs, this, and this, and that will allow us to calculate the perimeter of sectors as well, because if we know the arc, we can simply carry on walking round. We can add on twice the radius, and that will actually be the case for all of them. So I want us to be able to solve problems involving arcs of sectors. The first thing I want you to do is I want you to look at these three sectors and estimate the number of degrees in each sector. So have a little go at doing that now. Pause the video and write down your best estimates. Okay, I'm going to carry on with this. Hopefully you've had a good go. So what we're going to do is we're going to write our estimates down. I'm going to have a little quick go at this. So this one is a bit less than 90. I'm going to do this quite quickly. I reckon this is 85. Oh, this looks quite small. I reckon it's 10. And then this is a bit more than 270, so I'm going with 285. So you should have three values in a very similar way. I'm going to see what the answers are, and then write the answers below. So, oof, I'm not bad. Then I want you to write down the actual answer below your estimate. Find the difference, and then so that's going to be 6, or that's going to be 14 minus 10 is 4, and then 3. So my total difference was 13. So what I'm interested in is, did you get a lower difference? Let me know if you did. Hopefully you're pretty close to that sort of mark. Okay, now the main question is, what if I gave you the radius of this sector on the left and asked you to work out the arc length? How could we do that? Well, we first need to think back, how do we work out the arc length or circumference of a whole circle with radius r? And that turns out to be 2 pi r. So here we don't have a whole circle, we have a fraction of a circle. What is the fraction of the circle? Well, it's 79 degrees. I want you to just have a little go at writing down what you think the arc length would be. If this is r, let's say it's 5 centimeters, what would we do for the arc length? Okay, I'm going to just pause the video and write down your best estimate. Alright, well done for trying that. So actually the answer is that it's going to be, well, the whole circumference of this circle, if we continued it, would be 2 times pi times 5. I don't want the whole circumference, I just want a bit of it. So I need to times by the fraction of the circle, 79 over 360. And actually that is going to be what we do in general. The arc is a part of the circumference of a circle. The arc shown is the fraction x over 360 of the whole circumference. So if I'm jumping from an angle of 79 degrees to suddenly having x. So I'm saying my fraction is x over 360. And then the whole circle is 2 pi r. So the arc length is x over 60 times 2 pi r. I'm just explaining where this formula comes from. This is not a formula I want you to just learn by itself individually. What I want you to do is have this understanding that 2 pi r is the circumference. This is the fraction. So of course we have a fraction of a circle with the sector. The arc length is this. So please make a note of this formula. Arc length is x over 360 times 2 pi r. Okay, so we're going to do some examples on calculating the arc length or calculating things similar to the arc length, or maybe we might know the arc length and work backwards. That's the sort of problem that we might be interested in solving. So example 1, find the perimeter of the shape shown. We've got a sector, 80 degrees, the radius is 4, and we want to work out the arc length. Right, well let's not forget we've got this formula above. Arc length is x over 360 times 2 pi r. In our case, r is equal to 4 and x is equal to 80. So in this first example, we're just substituting in arc length equals 80 divided by 360 multiplied by 2 pi times 4. Okay, so I'd like you to work along with me, put that in your calculator. Okay, and what I get is, we could write it exactly, to be honest, for the time being, 16 over 9 pi. This sort of question, because it doesn't say leave your answer in terms of pi, we're going to want to write it to some number of significant figures, but this isn't actually the answer, is it? What we have done so far is we basically, with this person on the edge of the sector, and we've walked here. That is not the perimeter. We then need to walk a further 4 and another 4. So the perimeter is going to be 16 over 9 pi plus 8. And at that point, put in your calculator, press SD to change it to a decimal. We're going to get 13.585. I'm going to write that down like to 5 figures, so I've not rounded it apart from after the 5th one. I've just written down, I'm going to do some dot dot dot, yeah, it carries on. And we're going to round it to 3 significant figures in this case, of 13.6 centimeters. Okay, we can now calculate the arc length of sectors using this formula. Example 2. Where can we go from here? Why would the examples not just be like this? Well, we're going to need to. We've done a lot of this this year. When you might have to work backwards, I'm going to give you the arc length here. It's 12, and I want to work out the angle. Okay, you could even have a go at this now. You could pause the video. I'm going to go through this, but you can pause the video and see if you get the right answer. Have a go. Okay, hopefully you've paused it, you've had a go. I'm now going to go through this question. So we know that arc length is x over 360 times 2 pi r. So that means I can straight away, do you know what, I am going to write it down. Arc length equals x over 360 times 2 pi r. But we know what this thing is. It's just 12. We don't know x, but we know what pi is and we know what r is. So we can simply substitute in. We can write down 12 equals x over 360 times 2 pi times 9. And now we need to be able to rearrange this. So what I'd probably do is I'd take it step by step. I would times both sides by 360 to start with. 12 times 360 equals x times 2 pi times 9. It's just gone from the right hand side with a times by 360. It's turned up on the left hand side. And then I'm going to divide by, this is 18 pi. Actually, 2 pi times 9 is 18 pi. So divide by 18 pi. Divide by 18 pi. It's going to go from here. It's going to end up over here. We're going to write 12 times 360 over 18 pi equals x. Only at this point would I get my calculator out. Hopefully you're doing the same. Then I get x equals 76.394, which again I'm going to round to 3 significant figures, 76.4 degrees. Done. So when we did rearranging equations earlier on, like, you can sort of see how important it is to get good at that skill, that algebraic skill, because it's used all over the place. Sometimes you do have to rearrange the formula first. Okay, last example. So we've done one where we've got R and we've got X and we want to find A. We've done one where we've got A, we've got R, we want to find X. That leaves just one that we've not done. It's going to be a similar sort of process, but what if I gave you the arc length, I gave you the angle, but now I ask you to find what R is. Okay, here goes. First thing, so if I was seeing this question for the first time, this would be what would be going through my mind. I'd be thinking, right, it's arc length. So I know that it's going to be the fraction of the circle. So you don't have to write down the formula in full, you can just go straight for it. The fraction of the circle multiplied by 2 pi r. Oh, but wait, I know what the arc length is. That's going to be 20. Okay, so you can either write down the formula in general, or we can just sort of use our intuition to get the formula for the arc length. Same idea now, basically, because x and r were both sort of, they're on the top, they were just multiplying. It's going to be the same process to solve, this time to find r. We're going to times by 360, both sides, so we get 20 times 360 equals, I'm going to sort of combine it together, 50 times 2 is 100. Actually, do you know what, I'm not gonna do that. I would normally do that, but I think purposes this example, let's do it slightly differently. So 20 times 360 equals 50 times 2 pi r. By the way, like, you could well have tried this example by yourselves first. That would have been a really good thing to do. Okay, what do I do now? Well, I'm going to divide by everything in front of the r. So I'm actually going to sort of divide by 50 times 2 pi all at the same time. And that is the same as divided by 100 pi. I just wanted to sort of demonstrate that you can do this. It's okay. So I'm not going to write it down on the right or left, but it's going to become 20 times 360 over 50 times 2 pi. Okay, put that in your calculator. And I get, sorry, I'm going to say that equals r, and then I'm going to write down r equals 22.918, which becomes 22.9 centimeters. Done. So from the arc length, I can work out the radius. So that's it, really. These are some examples. I'd now like to practice some questions. If you're really confident, you don't have to do sort of like there's 4 that ask you to find the perimeter. If you think after the first 2 you got this, then move on to the next ones. Get onto the later questions and challenge yourself. If if you think I really want to do the practice, I want to put the effort in, and just make sure I'm really happy with this topic, then go at a slower pace. I ask you to find the angle a bit later on, and I ask you to find the radius, and then there are a couple of questions at the bottom that I'm not going to do an example on this, but it's using the knowledge you have to think about the perimeter of something like this. And this one, I give you the perimeter. So please, if you do try these 2 challenging ones as well. I've basically taken questions from a textbook and just cropped out some of the ones in between. So in the textbook, I think they had, say, 8 questions just finding the arc length or perimeter, and I've given you 4. So that's why the numbering's a bit different. You've seen this in my lessons before. Right at the end, I'm going to show you the answers. Here you go, so you can check how you are doing. I can't mark everybody's efforts, and I'm going to leave the answer to the starred questions off. I want you to post them to me, like let me know what you got for it, and then I'll let you know if you got it correct or not. Okay, so have a go at these questions, and thank you for watching.